thing I'm going to give you is the intuition behind what we call KNN, KNN, which stands for K nearest neighbors. And the way that your book is doing this, they're doing it, I think, with continuous output and what we call classification. So that was what was the intent behind your project, was a classification problem, but you can't mix and match. Classification means you're bucketing people into groups. And so it's used to predict by classifying things into groups. Typically, you have data, this. For your class, you're just going to have X and Y coordinates. And there's going to be like a number here, and then there's going to be a classification. 1, 2, 1. So there's a known classification. This data is known. This kind of data is called training data. So you're actually right in my wheelhouse right now. This is machine learning. So you're learning a little bit of machine learning, which is very, very cool. But we have tasks oriented around this. And so the issue is really like, how do you learn this much stuff and execute it properly on an exam? That's what I'm kind of worried about. But it is really, really cool that you're doing this. I think Colonel Linkos told me they're doing KNNs. So what you primarily will be doing is when you have XY data and you have a classification. So real actual KNN applications have lots more than just 2 variables and classification. One example is on your phone, if it recognizes your face. It's classifying your face and not your face. So there's 2 buckets. And every time it looks at your face with an image, it tries to classify. Mine right now doesn't recognize me if I have a ponytail. But the more I keep pushing my finger on that, it like takes that as more training data. So any new picture that it gets of me, a new picture would be me actually just looking at my phone. It has to recognize me and classify me correctly. That's exactly what this is doing. So training data is the data that you have where it takes known pictures of me, where we can call it labeled data. We know the output. And then you develop that algorithm around that training data. And then a new face comes out and says, that's not Dr. Thomas. That is Dr. Thomas. That's the new data. That's called test data. That's image recognition. It's probably the most well-known application of machine learning. So over here, your algorithm has to be really good because this is the data it's training on. It's not any different than you guys learning something. Close laptops, please. It's not any different than you guys learning something. You're learning something new, you test it in here, and then on the day of the WPR, you go in, that's your test data. Same thing. That's why they call it machine learning. It acts very much similar. So the intuition of how this works is the following. Let's say I'm going to put everything up in this quadrant because most applications are positive reals. You'll have a bunch of data, These are your points. And then you'll have some other data. I'm noting them with different notation, like triangles. I'm losing my train of thought. I'm old. So here you've got clumps of data that's plotted. And then you have your new variable, like this. This is your new test data. K nearest neighbors is like the mindless way of assigning this category. And the mindless way is just look at the distance it is between the points over here and the points over here. And I'm just going to take the 3 nearest points. So So what you're going to do is actually take the distance between all of these points. You're going to look at this new point and the distance here, 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 the distance here. Take the 3 closest ones, the smallest distances. What formula do you use? Distance formula from high school, maybe grade school for you guys. I know they're teaching these things earlier and earlier. So you take your 3 closest ones, and 3 is going to have a vote. So 2 out of the 3 are going to be one of the classes. If you only have 2 classes, right? They have to be. And so you just take the majority. It's like they each have a vote. So you take the 3 closest distances, they all vote. This is in the triangle class or the square class. 2 of them have got to be the same, right? That's your prediction. All right, I didn't give you an example. I just gave you intuition behind this. This is the intuition. You do have to understand this. One more thing to understand. Sometimes one variable is huge compared to another variable. And the distances on the x are going to be spread out, and the distance on the y are going to be really close together. So you have to standardize the data before you do any of this. Otherwise, you have a huge scale here that's going to weigh so the distance is going to be just because it's spread apart on the x-axis. So what we do is something called standardization. So in the worksheet I'm going to give you, that standardization is built in there. You can write these steps down in the formulas, but you have to understand why you're doing it. You kind of bulk up the data. It's the same thing as body mass index. Body mass index is a standardization of everybody's weight. Like, it's not going to happen, but pretend you and I had the same weight. Well, you're taller than I am. So if I just looked at body weight alone, that's not enough information. So when we divide by height squared, it's taking your tallness and standardizing us both by height. So now I can compare us to. That's the same thing when you have the x and y axes and you standardize. You now make the scale the same so you can compare them in the correct way. Does that make sense? Does what I'm saying make sense? Because this is kind of like machine learning is hard. I always say that anybody who wants to jump in, I always have people who want to jump into machine learning because it's the in thing right now. Like, you vastly underestimated the complexity of what I'm doing. If you feel that I can just teach you in 5 minutes, but I'm trying to teach you in 5 minutes. So does everything I'm saying make sense? Ask me questions. We're going to try one. And I built it out with steps so that you can put it on your formula sheet so that you have it, right? Because you're learning a lot of stuff. You're not just learning this. This is the hardest thing I think you have to learn. I think for up to the next WPR. This is the hardest thing. All right. So we're going to try it.